Okay. All right. It says use substitution. Do not solve that at all. Don't factor it. Don't or complete the square. So just substitute it in. Well, what does that mean? Take that x out. Put in 5 minus square root of 2. And what do we got to do to that? Square. Minus 6 times 5 minus square root of 2 plus 8. And I'm going to put a little question mark here because we are checking to see whether it equals 0. All right, if this is true, if this is a solution, when we're done, we're going to get 0 on the left-hand side, right? Well, there's a lot of math going on there. A lot of places to mess up. And this is where I get you at least started. What do we do here? 5 minus square root of 2. You have to square it, which means we're going to have to do what? Distribute it. I'm going to say FOIL. We'll be talking the same thing. We got to FOIL it. We got to take 5 minus square root of 2 times 5 minus square root of 2. All right, let's jog the memory banks here. Okay, how do we actually do that? FOIL, first, outer, inner, last. 5 times 5 is 25. And I'll come back over here. Okay, 5 times negative square root of 2. You cannot multiply a number outside by a number inside. The only way you can represent that is minus 5 square root of 2. 5, the square root of 2 times 5, or negative square root of 2 times 5 gives me the same thing. And all right, what's negative square root of 2 times negative square root of 2? Positive 2. Remember, square root times square root just leaves you that number. If I simplify that, I get 27 minus 10 square root of 2. All right, so a lot going on there. So now that is just that squared. So now I got 27 minus 10 square root of 2. Distribute, negative 6 times 5 is minus 30. Negative 6 times negative square root of 2 is plus square root of 2 plus 8 equals 0. All right, combine like terms. And 20, I got 27. I got minus 30. Well, I'm just going to group them here for this. I got 27 minus 30 plus 8 minus 10 square root of 2 plus 6 square root of 2 equals 0. That gives me 5 minus 4 square root of 2. Does that equal 0? No, so what can you tell me? Cole, what can you tell me? Yeah.
That's not a solution.
Not a solution. Okay, so it's wrong. So x equals 5 minus square root of 2. Whoa. Is not a solution. Okay, good. All right, on your homework. You did not have to do 46, but you might want to copy down the answer to 46 because you'll have to do that tonight. I'll move it down here in a second.
For the first problem that we, the one that we just did.
Yes.
Could you have also solved like by completing the square and then seeing if any of the answers were?
No. Because what are the directions say?
Oh, I see that. But I mean, if it wasn't that question, if it didn't say use substitution,
Right. Then you could.
Okay, got it.
If you're just checking to see whether it's right, but according to that, you got to follow the direction. You got to use substitution because we're just seeing if you can do that route. But yes. Go ahead, go take a look at these answers. For the most part, is what I looked at was pretty good. Just a minor hiccup here and there. But check those answers, and then I'm going to move it up and actually write down 46 because you'll do that tonight. Mark, you got to solve. You just factored. Huh? You didn't solve the problem.
Oh, I see, yeah.
Yeah, you just factored them and stopped.
This one.
What's that? Oh, yeah. 96. What's that reduce to? Reduce to what? 3 halves. So you're good. You're good. All right, 46. Okay, there's the answer to 46. I do want to just talk about 74 real quick. A couple of things on there. Tyler, what's the original problem for 74?
18x squared plus 57x plus 45 equals 0.
18x squared plus 57x plus 45. All right, how'd you start it? What'd you do?
I did took 6x into 3x out of 18.
Say it again. You took 6 and
6x and 3x out of 18.
so 6x and 3x. Like this? Oops.
Yeah.
Okay, and then what'd you get?
I got plus 9 and plus 5.
Plus 9 and plus 5. Okay, so 6 times 5 is 30. That's 27. Okay. If you did it this way, you're okay. And if you didn't, don't worry. Just don't change anything. And so you solve those 6x plus 9 equals 0. 3x plus 5 equals 0. And then subtract 9. Negative 9, 6. Negative 5/3. 9, 6 reduces to what? 3 halves. So it's the same. Now, 6x plus 9 has a GCF of what? 3. That tells me something. That tells me there's a GCF in the original problem. What was the GCF of the original problem? Okay. 3. So you could have taken a 3 out right away, and that would have given me 6x squared plus 19x plus 15 equals 0. This factors into 3x plus 5, and then 2x plus 3. Okay. Now here's one thing you got to watch. Some of you, not many, but a few of you put down 0 as one of your answers because you had a GCF out there. 0 will not be an answer because there's no variable with it. When we did the example in class, we factored out a 3x. If there's a variable with this right here, that will give you an x equals 0. Technically, this is just 3 equals 0. That there's no or 3 equals 0. There's no variable involved. This will still give me negative 5/3. This will still give me negative 3 halves. Okay, so just be careful on that one. If you do factor GCF out, and it's only a constant, that does not give you that additional answer. Has to have a variable with it for that. All right, any other questions on your part on that? Yes?
What are the answers to 61 and 41?
Those in your book. I'm not going to put you, I'm going to count on you to check those on your own. Okay, all the odd answers, what you need to do is just go through and do those on your own, okay, in the back. Because I don't remember, I don't usually list the evens. All right, we did this one in class, right? Completing the square. All right, I'm going to do it again just to kind of go through it. Then we're going to do a harder one. Okay, a harder completing the square. But let me just go through this again. Watch. If you want to write it down, fine. If you already got it down and just want to watch, whatever. We talk about step 1. Isolate the constant term on one side of the equation. So move that 4 over. And when you move it over, you got to subtract it. Make the coefficient of the x squared equal to 1. It already is. That's life's easy. Okay? So step 2 we don't need to do. Complete the square. That is where we figure out this number that'll make that a quantity squared. The procedure is you add the square of 1/2 the coefficient of x. Take half the coefficient, square it. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. So that goes here, that goes here. Now that factors into x minus 3 times x minus 3. And yes, I know you're probably just going to go and jump right to x minus 3 squared equals 5. That's fine. Now you take the square root of both sides. Square root x minus 3 squared equals plus or minus square root of 5. X minus 3 equals plus or minus square root of 5. Add 3. All right, a lot of times people just kind of forget to add, and then they write down the wrong sign in front of it. I mean, just a minor issue, but be careful. All right, that's your answer. Good. Procedure, we got to figure out that 9 so that it factors. All right, now let's look at one that admittedly is a little bit harder. Okay. Two m squared minus 5m plus 8 equals 0. I'm going to move the 8 over and make it equals negative 8. Okay, on this, it didn't happen on the last one, but step 2 says make sure your squared term has a coefficient of 1. Well, what's our coefficient here? 2. It has to have a coefficient 1. It's not like you would like it to, it has to. You have to divide each piece, everything, and don't forget this middle term, by 2. Now, when we're completing a square, I don't want no decimals anywhere in your work or in your answer. Okay, so don't make that 5 over 2, 2.5. Do not do that. Keep it as 5/2. And I'll write it down here in a second. No decimals in your work or answer. Okay, so that gives me m squared minus 5/2 m plus, I'm going to leave a blank here, equals, well, negative 8 divided by 2 is negative 4. That reduces to a whole number, so that's fine. Don't leave it as negative 8 over 2. It reduces. But 5/2 do not put us 2.5. All right, now, for the last one, most of you, if not all of you, could figure out what goes in that spot. Not as easy. Not as easy. What's good? So we need to rely on that procedure. Well, the procedure said take half of the coefficient of m. Well, dividing by 2 is the same as multiplying by a half. So I'm going to multiply it by a half. Negative 5/2. Hold on. Let me make it negative 5/2 times 1/2. Well, what's that equal? Negative 5/2 times 1/2 is negative 5 over 4. All right, what do I still need to do? What do I got to do? Square. I got to square. Now, be careful here. What is negative 5 over 4 squared? It is positive 25 over 16. That is what goes in. That is what goes in both spots. Okay. Now I'm going to take my time here. So that's m squared minus 5/2 m plus 25 over 16 equals, all right, what is negative 4 plus 25 over 16? Yeah, you can type it in your calculator. That's fine. Keep it as a fraction, though, if it comes out. But I like to practice. So make that a common denominator, 16. And that's going to be 64, negative 64. So it's negative 64 plus 25. Okay? Negative 64 plus 25 is negative 39 over 16. So that's going to go here. All right, this is going to be m, since that's a minus something quantity squared equals negative 39 over 16. All right. Aaron Hess, do you know what goes there? Do you remember? No? Okay, good. We gotta know. Josh, do you remember?
5/4.
5/4. And how'd you come up with that?
That was half of,
It's already, yep. There's no big trick involved. Whatever half of that coefficient is, that is what is going to go in there. That's always gonna be the case. Always gonna be the case. Now, let me back up for a second. So we had x squared minus 6x. Well, half of 6 is 3. We ended up with x minus 3 squared. It's a little bit harder and not as obvious when you got fractions, but that is the case. Now, m minus 5/4, just to show you, if you FOIL that, m times m is m squared minus 5/4 m minus 5/4 m plus 25/16. What's negative 5/4 m minus 5/4 m? Remember how you add? You just add the numerators. It's 10/4. But what is 10/4? That's the same as 5/2. So it's not as hard as it looks, as long as you recognize that little tip there. It's just going to be half of whatever you take the coefficient of. All right, now take the square root of both sides. Square root. M minus 5/4 squared equals plus or minus square root negative 39/16. Well, the square root of m minus 5/4 squared is m minus 5/4. I really want to treat it as the square root of the numerator and the square root of the denominator. Do we know the square root of negative 39? No. Do we know the square root of 16? 4. Use that. So it's now plus or minus. Now make sure that once you write the 4 down, it's no longer under square root. If you do this right, these denominators should match up. If you do this right. If you do it wrong, you shouldn't get a 4 and a 6 or a 4 and an 8 or anything like that. You should get the same thing. Move the 5/4 over. Now, since we have the square root of negative, remember how we handled that? Okay, that's going to be basically anytime you got a negative under square root, it comes out as an I. Remember, it's an imaginary term. So it's plus or minus I square root of 39/4. If you left that, absolutely fine. But a lot of times you will, or people will, since they have a common denominator, you could write it as that. Okay, same thing. I'm fine with that top answer. Some people like to write it like this. Either way is acceptable. Okay. If you do get a square root under negative, pull that out. Now, square root of 39, you want to reduce it if you can, but it's 3 times 13. It doesn't reduce anymore. You're done. Okay. All right, so this is much more complicated because you're dealing with fractions. Keep everything in terms of a fraction. Do not give me any decimals anywhere. Okay, because that'll mess things up as we get to the end. All right, so we got factoring, we got completing the square. What's the third way? Quadratic formula. Okay, so we at least got to talk about that. Here's your quadratic formula. I know you proved it last year. I know a few of you probably want to prove it again, but we're not going to make you. I mean, if you want to do it for fun, I mean, that's okay. No. Really, you just need that bottom part. X equals negative b plus or minus square root of b squared minus 4ac all over 2a. Remember, this is a case where it does have to equal 0. You're going to have to manipulate it if it doesn't. It says it equals 0 for that. All right, let's take a look at this case here. All right. This is probably the only one you'll ever get where everything just set up nice equals 0. So you know what your A is, you know what your B is, you know what your C is. All right, I'm going to substitute it in. A is 2. Let me put it over here. B is 5. C is negative 7. And we know X equals the opposite of B. plus or minus b squared minus 4ac all over 2a. Let's see, what do we get? Negative b, negative 5 plus or minus 5 squared minus 4 times 2 times negative 7 over 2 times 2. Now for completing a square, if you got a number in front of x squared, this one would be really nasty to do completing a square. Okay, so that's where I'd use quadratic formula. All right, at least figure out what number do we get underneath the radical. Okay, so what's 5 squared? I want to at least write that. Don't do too many steps at once. 5 squared minus 4 times 2 times negative 7. Maggie Purdy, what's that going to be? What do you get? $137. Ooh, what number are you punching? 5 squared minus 4 times 2 times negative 7. 81. Yeah, I'm not sure what you get there. All right, you need to simplify this as completely as you can. So do we know the square root of 81? Yeah, that's what? 9. So this becomes now negative 5 plus or minus 9 over 4. Don't leave that as an answer. Break it down to the two whole numbers or fractions that we get. So this becomes negative 5, x equals negative 5 plus 9 over 4. And then the other one is x equals negative 5 minus 9 over 4. All right, keep going all the way to simplify. What's negative 5 plus 9 is 4. 4 divided by 4 is 1. So it's just a 1. Don't leave it like this when one of your answers is 1. All right, now the other one is negative 14 over 4. You can leave this as negative 7 halves is fine. So those are your two answers. Negative 7 halves, 1. All right, do you know, just without even going back and trying, was this problem factorable? Okay. Just by looking at that answer, you should be able to tell me yes or yes it was factorable or no it wasn't. All right, so any ideas? Ryan?
I think it was.
Why? What's the key thing?
Because there's two values for x.
There are two values for x, but let's see here. That doesn't guarantee it. Doesn't guarantee it.
Because they're both real numbers.
They're both real numbers. Well, you're counting that as square root as a non-real number. That's a real number. So I think you have the right idea, but you just phrased it wrong. They're both rational numbers. They're both rational numbers. Here's the key, right here. Right there. If that square root is a whole number, then it was factorable. Well, this set to be a square root, it has to be a perfect square. So here's the key. It says if the discriminant. Oh, it's been a while. Do you remember what that discriminant means? The discriminant is b squared minus 4ac. Okay, whatever's underneath there. If it is a positive perfect square, something that we know the square root of, then the original problem is factorable. Now, I wouldn't go back and factor it because you know the answers, but sometimes you can take a quick look and say, hey, maybe it's factorable, maybe I don't have to do this. So just that is kind of the key. And then it'll give you rational numbers, fractions, okay, and whole numbers. You will not have any radicals or i's. Okay, no radicals or i's. All right, does that make sense, hopefully? All right, let me see something. I'm going to switch some things around. I'm skipping number 2. We don't need to do 3 of these. I'm going to go to number 3. Go ahead and write that down. Ryan, here's your quiz. I had it. I think you were asking today. All right, this is more like what you're going to see. You're not going to see a bunch of problems where it's already set up. You're gonna have to do a little bit of work. You're gonna have to remember it has to equal 0. And so for this, distribute your 4. 4x minus 12 equals 2x squared plus 3. And I know you've been trained to move everything to the left, but I'm going to tell you, I'm going to always try to keep my x squared positive. Just, it makes life a little bit easier. So I'm going to move everything to the right, and then I can flip it later. But subtract 4x, add 12, and that gives me 0 equals 2x squared minus 4x plus 15. And now if it really makes you feel better, just flip it and put 2x squared minus 4x plus 15 equals 0. All right, go ahead and take it down until you find out that discriminant, whether it's a perfect square or not. Okay, so take it down to whatever that constant is. All right, yeah, let's see what we got here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. So x equals the opposite of negative 4 is 4. Negative 4 squared minus 4 times 2 times 15 over 2 times 2? 4. All right, Mia, what'd you get underneath the radical?
Negative 104.
Negative 104. 4 plus or minus square root of negative 104 all over 4. I agree. Now we got to simplify that. That radical simplifies. Square root of 104. Now the negative comes out as an I, so you really don't need to worry about that when you're simplifying it. We'll do that in a second. All right, but take a second, see what you remember about what that would simplify to. And what I mean by that is like the square root of 18 simplifies to 3 radical 2. The square root of 24 is 2 square root of 6. Okay, just reducing it a little bit. Okay. Mackenzie, you know what it reduces to?
No.
You don't remember how to do it?
No.
All right, anybody remember how to do it? Tyler, you remember how to do it?
Not really.
Not really? Oh, man. I guess that's why I get paid money. Mia?
I could pull out like 4 and 26.
So what was the final answer?
2i squared root of 26.
It would be 2i square root of 26. All right, now, a couple ways you can do it. 104, you can go old-fashioned and do factor tree. And look for pairs, okay? Like when you're reducing radicals, you can factor tree it out, and then you can say, all right, I got a pair of 2's. That gives you 1, 2 on the outside, and anything else left you multiply back together. Or you can look for perfect squares, like 4, 9, 16, see what goes into that. I think the only perfect square that goes into that is 104. Excuse me, is 4. 4 times, what is it, 26? And then 26 is 2 times 13. Square root of 4 is 2. But either way, you got 2i square root of 26. So now what do I got? X equals 4 plus or minus 2i square root of 26 over 4. All right, that can reduce. You take a look. All 3 of these have to have something in common. Not just 2 of them, all 3 of them. It's that 4, that 2, and that 4. Well, what can divide into all of them? 2. So reduce everything by 2. So you get x equals 2 plus or minus, and you can just make that an I, square root of 26 over 2. Got to do that. You got to put it just in the proper format. Okay, I know they're equivalent.
Could you have also written x equals 1 plus or minus I times radical 26 over 2, because it separating the 2 and the I radical 26.
So making that a.
It-
Okay, so usually they don't do that. So you're doing this as 1 plus or minus I square root of 26 over 2 like that.
Yeah.
You don't see it written that way. That is equivalent, okay, to that because you just basically put them both over 4. Okay. Normally, what we keep it in that terms, unless these both come out to be whole numbers. Okay. I mean, I'm not gonna mark that wrong, but I don't see it too often. All right, so we're gonna leave that. All right, now this next slide here. I just want to talk about simplifying. These are like answers you could come up to, and I just want to either pay attention. You can get them down if you want to, but not a huge deal. But let's say that's your answer. All right, this is not correct because what would we still need to do? That square root of 48 simplifies. Well, you can either do a factor tree or you can figure out what whole numbers. All right, take a second. Since a lot of you forgot, see if you can figure out what the square root of 48 simplifies to. Okay, just kind of do that on your own. All right, Gavin, you know it?
Yep.
What you got?
4 square root of 3.
4 square root of 3. Did you do a factor tree or did you just figure it out?
Figured it out.
Okay, it is 16 times 3. 16, square root of 16 is 4. Got to be the same. If you do a factor tree, 2 times 24. 4 times 6. 2 times 2. 2 times 3. Any pairs come out, whatever's left stays in there. So you do have to get 4 square root of 3.
When you're finding the perfect squares, do you choose the biggest one that can go into the middle?
Yes, because if you say, if you did 4 and you made it 2 square root of 12, it's simplified, but is it completely simplified? No. Then you could simplify 12 again into 4 times 3, and then that comes out and multiplies, so you end up with that. So you still got it, regardless of how you get there, that's got to be your answer. Okay. So now, I got x equals 6 plus or minus 4 square root of 3 over 4. All right, see if they all have something in common. They all have a 2 in common. So then you make this x equals 3 plus or minus 2 square root of 3 over 2. All right, for that one. And in this case, typically they're not like broken up like you talked about. Just leave it like that. All right, now I do see mistakes here. And here is, this is probably what I see the most. What's incorrect about that? Okay. Oh, you're just scratching.
I mean, the 8, radical 3 should be over 5.
Right, you cannot just say 10 divided by 5 is 2. It has to go into all 3. I would tell you to leave this answer right here. I would tell you not, don't even mess with it. Now, if you were saying earlier, you might see some people do this. If you write it as 2 plus or minus 8 square root of 3 over 5, now that would be okay. Now that's correct. I'd still say leave it up here. Okay, but that's clearly wrong. Okay, know the differences. All right, we got completing the square, we got factoring, we got quadratic formula. Okay, they all have their uses. And we're going to talk about the discriminant. Now, this comes up every now and then. We said b squared minus 4ac is the discriminant. That just gives us some information about the types of answers. Do you remember? Actually, this is just kind of logical. If b squared minus 4ac is greater than 0, if it's positive, what type of answers do we get? Okay, now, basically, we get 2 real solutions. They could be rational if it's a perfect square, but they're always going to be real. And now we just throw in a little bit of extra there. They're not going to be the same. You're not going to get a 3 and a 3. you're gonna get two unequal real solutions. If it is less than 0. Okay, if it is less than 0, that is where we get the i's. And we just say two complex solutions. But what if it equals 0? What if it equals 0? Then, remember? We get one solution. Okay, and it is a real solution, it's not a complex. Okay, one real solution. You will get this every now and then, and you just have to make sure you answer it correctly. More often than not, people just go and solve it. You don't need to solve it. It just says determine the number. Are there 2 or are there 1? And type. Are they real or are they complex? From an equation. What's the only thing you need to find? Discriminant. Just find b squared minus 4ac. Go ahead and do that. Let's see what you get. Kayla and Zaka, let me know what you get. Negative 44. All right, so I got a negative number, which is less than 0, so that means I have 2 complex solutions. 2 complex solutions. All right. For that. All right, so that's solving quadratics. I mean, there's a ton involved in there, but just stuff you've had before. Obviously, it helps to get reminded. All right, get started on this. 13 and 46 might be the 2 harder ones. Like 46 is completing the square and has a coefficient. If you get stuck on either of those, I want you to see me before you leave. So try and get done with 13 and 46 before you leave. And then most of the others are either just solving any way possible or quadratic formula. But I do want to see the 13 and 46 here, or I'll be around to look at them. Let me shut off.